In a question like this, it is advantageous to recognize that because you have a root 2, it very likely is a special right triangle. More specifically, let's go ahead and pull up our reference document, and we can see there's two types of special right triangles. Well, the one that has a root 2 is the 45, 45, 90, which they call S, S, S root 2. It could have been X, X, X root 2. They just didn't want to confuse us because these have X's in them. And so let's go ahead and get things in a position where we can see this reference document, basically in the corner here without interfering, and we can start using it to our advantage. So let's go ahead and start with the fact that this triangle here, the one that had the root 2 in it, very likely is a 45, 45, 90. Now we could use Pythagorean theorem to get this missing side, but let's see this through. If we notice that the two legs would be congruent in a 45, 45, 90, if this were 6 root 2, would this make sense? Well, if this is normally S, and this is S, and this other one is S root 2, well, that would mean that we're saying 6 root 2, 6 root 2, 6 root 2 root 2, and root 2 times root 2, in other words, root 2 squared, is 2 since the square and the square root cancel. Well, 2 times 6 is 12. So this does satisfy a 45, 45, 90 right triangle. And the significance of that is we can then use that to our advantage to transition over to this right triangle. And notice they're saying this is a right angle up here. Well, if this is 45, 90 minus 45 gives us this theta as 45. Well, then we have another 45, 45, 90, which is always an isosceles right triangle. And so if this is x, then we know that the other leg is also x, and the hypotenuse is x root 2. Well, if you solve for x by dividing by root 2, you can see pretty easily that you're left with x being 6.